Hello learners, we were discussing about the design of the beams, right? So we have already completed 2 to 3 set of beams. Okay, yes, just a minute. Yeah, we have already completed 2 to 3 set of beams. We have already completed design, right? So so let us go to the next design of the beams, right? So these 2 set of beams is already been done. Now let us go to this beam number 10, 11 and 14. If I check this 10, 11 and 14, you can see that for 10, 11 and 14, for all these 3 beams, the dimensions of the beams are same, right? So therefore I can go for 10, 11 and 14. Okay, I can go for the design of 10, 11, 14. So again I am using grade of concrete as 25 and the grade of steel as 415. So your breadth of the member is 300 and the effective cover is 20. So therefore you will get the effective depth 550 and the overall depth will be 570. And now according to this value of this, your design shear force is low compared to the moment, that is 93.94. I can make it as 94. Okay, I can make it as 94. And when it comes to the positive bending moment and the negative bending moment value, you can see that the positive bending moment value, so you are going to get it as 88 and the negative bending moment value as 120. Okay, your positive bending moment value as 88, I can make it as 90, and the negative bending moment value I can make it as 120, right? Yes. So let us find out the corresponding mu by bd square values of this both. Now according to this, it is 0.99, means I can almost take 1. I am supposed to take this table of FCK as 25, and it is 1, and for 415 the percentage of steel, okay, that what you are going to get will be 0.291. Okay, it is 0.291, and whereas for this, that is 1.3, if you see 1.32, so I can go to this 1.32, yeah, almost 1.32. I can say this value, higher value, as 0.401. okay, 0.401. so these are the corresponding percentage. So therefore I can find out the area of the steel required. So this is the corresponding area of the steel. I'll be providing as usual 16 and 20 mm dia bars. So these are the area of the individual rods. So therefore you will get the number of rods required. You can see that the number of rods required here will be 2.47. I can make it to 4, next even number, and this also I can make it to 4, the next even number. So then next what you are supposed to do, the nominal shear force already it is given, so which I can directly take here, 94. Okay, so definitely when I calculate the nominal shear stress value, so this will be the nominal shear stress, and this will be the AST, and this will be the AST that you are going to provide. So therefore the percentage of steel, if you calculate, it is 0.48. I can take it as 0.5, and from this table 19, 0.5, and the grade of concrete is M25. You can see it is 0.49 is the permissible shear, 0.49 is the permissible shear, and this will be anyhow 3.1, it will not change, right? So 0.49. Therefore if you see, the permissible shear is 0.49 and the nominal shear is 0.59, therefore you are supposed to design it, and anyhow this is not more than this, therefore safe. Supposed to provide the shear reinforcement value. This is VUC value, and this is the corresponding VUS value. I am using this 10 mm only, so this will be the one, and you can get that the spacing you are getting very high spacing because this is very less. Okay, to be frank, this value you can see that it is 270 minus 97. You are getting here 94 minus 83, very less value, right? So therefore what you can do, it is not possible, this is a wrong spacing. So therefore you can provide the minimum of 300 mm spacing which is required. Without fail you are supposed to provide minimum of 300 mm. Yes. So that is about this beam. Now when I go to the, so therefore this set of beam is done. Now when I go to this beam, that is beam 4 and 6, if you see beam 4 and beam 6, again they are of same dimension, therefore I can go to beam 4 and 6. So I can go to the beam 4 and 6. So this will be same, this will also be same, this is also same. What about the shear force? The shear force according to this will be high, 228. It will be 228, right? High shear force is there. What about the positive and negative bending moment? You can see 132 and 141. That is the positive is 141, negative is 132. So 141 and 132, right? So if you calculate the value of this, you are going to get this 1.5, that is I can take it as 1.6 and 1.5. So if you see the table, the first one will be 1.6, it is 0.482, and next is 1.5, 1.5, .449. So therefore if you calculate the area of the steels, you can see that these are the area. I will be maintaining this 16 and 20 mm diameter only. Therefore this will be the area of the individual one. If you calculate the number of bars, you can see that it is I can going to provide the 4 bars, or I can go to 6, no issues, and this is going to be the 4 bars, right? And this, if you see, it is 228, and the corresponding shear stress will be 1.38. This will be the number of providings, so this one, so therefore 0.73. if you see 0.731, it is nothing but 0.57. so definitely 0.57 means, so it is the lower than 1.38, so therefore it has to be designed for the shear, and this is safe. Therefore if you see this will be the VUC value, this will be the VUS value, this will be the dia of the stirrups, so this will be the spacing 238. I can make it to 200. Okay, yes. So that is of this set of beam. Next you have 43 and 44. Just check what will happen. 43 and 44, again the dimensions of the beams are same. I can go 43 and 44. 43, 44. So this will be the gray, this will be this, the corresponding, 1 second, yeah, 300. This also, these values will not change. Yes, so now if you see the shear force here is very high in this. If you see the shear force will be around 355. Okay, whereas the positive and negative bending moment value, positive is 504 and 170, right? It is 504 and 170. So this is mu by bd square value, and this is the corresponding the negative bending moment value. If we see that the positive bending moment value is very high, that is mu by bd square value, you won't get it from the table itself. Okay, you won't get it from the table itself, because from the table the last value is this one. So therefore the maximum reinforcement that I can provide is 4%. So therefore let us give the value of 3% of the steel. Okay, or because here everything whatever I am doing is a singly reinforced beam, in such case we are supposed to go for the design of doubly reinforced. So that design of doubly reinforced beam definitely I'll explain you when I take up the next, that is second project. So therefore let us take the percentage of steel here as almost the percentage of steel I can give the value as 2% of steel I can give, and this I can get 1.8 value I can get it. So since I can get the 1.8 value, it is 0.549. okay, it is 0.549. Therefore if I calculate, so this will be the corresponding areas, and I'm giving 16 and 20 itself. Therefore if you find out, these are the individual areas, and if you find out the numbers, so these are numbers. You can see that this is not at all possible to provide, it's very difficult. Okay, either even this also I'll change this to 20. Even if you do that, you are going to get almost 10 numbers. Okay, so very difficult to provide. So let us go that we will see what to do when I am going for the final reinforcement and the detailing value. So let us give the 12 numbers and here 4 numbers. Okay, and this will be the corresponding shear. This is also very high, 2.15 is the shear stress value. Okay, so if you see and this is the one, this one, this is 2.285. if you see 2.285 here, okay, 2.28 means almost 2.3 I can say, 2.3, or I can go to 2.25 with 0.85 value. Okay, 0.85, and definitely this is higher I'm supposed to provide, and it is not more than 3.1, therefore safe. Therefore if you see this, this will be the corresponding the stirrups. So this will be the corresponding spacing, 148. I can make it to 140 mm to center to center. It is very difficult to provide, so go to 12 mm. So therefore you will get 200 mm, right? Okay, so that is about beam 43 and 44. Next I can go to the beam 8. Okay, I can go to the beam 8, right? So beam 8, 310. So beam 8, here to here no change, so this will be 310. And what about the bending moments value? 332 and 150, 332 and 150. Okay, so therefore what will be your mu by bd square values? Yes, so 3.6, 3.6, it is 2.099. sorry, Fe415 is not there, so this is the maximum value, 1.189. okay, so 1.189. and what about 1.65, 1.65, 0.499, 0.499. therefore if you calculate these values, this will be the one. I'm going to provide 20 and 16. okay, so 20 and 16. okay, so therefore if you calculate, so these are the corresponding areas So the number of rods will be 8 and 6, and this if you take, so this is the corresponding shear stress, these are the reinforcement you are going to provide. 1.52, if you see 1.52, okay, almost here it is 0.74, and definitely 3.1 safe you are supposed to design. This will be same, this will be going to provide 10 itself. Now I can provide the spacing of or if you make it to 12 itself, now you can make it of 200 mm, right? Okay, so that is of beam 8. So the next that you can have is beam 32. Beam 32 is here. Beam 32. Okay, so beam 32, that is also very high value, right? So beam 32, right? Yes. So let us continue our video in the next class with the remaining beams. Okay, thank you learners.